All right, let's talk about some bonding basics. Ready? Okay, first, energy and bonding. So chemical energy is stored in chemical bonds. So this is also why digestion is a thing, because when we break down food, we get energy from it. So when things are bonded together, energy is stored in that bond. How do we break a bond? Well, think about this. Here's this pencil. It's not just going to do anything on its own. So to break a bond, I've got to add energy in. I've got to put energy in. So when bonds are broken, energy is absorbed. So you can see right here, these two atoms are bonded together. In order to separate them, in order to break the bond, I've got to add energy in. And that is called an endothermic process. So I got to put energy in to break the bond. So I started with them together, bonded. I put energy in and I separated them. I ended with a broken bond by putting in energy. When I form bonds, on the other hand, it's the reverse. So when bonds are formed, energy is released. We end up with something more stable. So that's exothermic. So here you can see I have two separate. Hydrogen and chlorine are separate. When they bond together, energy is going to be released, exothermic. Remember, there's always conservation of energy, so just something to think about. The total amount of energy in the system stays the same, but you can see a whole lot of energy is released as heat and light when two hydrogen atoms bond to become a hydrogen molecule. Okay, what happens to the electrons in bonds? Well, what are electrons? Well, they're negatively charged subatomic particles. They're found in orbitals surrounding the nucleus of an atom. Remember, the electron cloud model is our current model of the atom. Which electrons are involved in bonds? Well, that's valence electrons. Those are the electrons in the outermost energy level of an atom. What happens to the valence electrons in metallic bonds? Well, in metallic bonds, the valence electrons are in a mobile sea of electrons. So the electrons are kind of just freewheeling, sliding around of all these positive ions of the metal, and then the electrons are just kind of able to move as they will. What about what happens to the valence electrons in ionic bonds? Well, in ionic bonds, the valence electrons are transferred from one atom to another. So in this case, this valence electron from sodium would get transferred to the valence electrons of fluorine. Ionic compounds are also called salts, and they're held together because of that strong attraction between positives and negatives. So we have positive cations and negative anions, and they are attracted to each other, and those bonds are so strong. And what happens to the valence electrons in covalent bonds? Well, in covalent bonds, the valence electrons are shared between atoms. So here are two examples. The electrons in the middle are shared so that each atom ends up with a full valence shell. Covalent compounds are called molecules, and we could have polar covalent where the electrons are shared unequally. We can have nonpolar covalent where the electrons are shared equally, and covalent compounds are called molecular compounds. Important to remember that. Now let's look at electronegativity and bonding. So what is electronegativity? Well, remember, it's the tendency of an atom to attract an electron in a bond. We talked about electronegativity before. Here's the chart. Look at fluorine. Fluorine, basically perfect electronegativity, the highest. Here's the lowest over here. Where do we find electronegativity values? Well, in table S. So right here, electronegativity values. How do we use electronegativity to determine bond type? Well, that's the new thing we're going to talk about. So we subtract electronegativity values, and it gives you information about the type of bond. And here's the general rule. that if the difference in electronegativity is between 0 and 0.4, it's going to be considered nonpolar. Between 0.4 and 1.7 is going to be considered polar, and between 1.7 and 4.0, it would be ionic. But the bonding is a continuum. It's not so cut and dry. So typically what we talk about is as the difference increases, the ionic character increases. Okay. And if we're looking at a difference of 0.4 and 1.0, 1.0 would be more polar. Okay. So ionic, remember, electrons are transferred. Polar, electrons are shared unequally. Non-polar, they're shared equally. And here's our general cutoffs for the electronegativity differences we're looking for. But let's see what kind of questions you might have. So in a hydrogen-oxygen bond, so a bond between hydrogen and oxygen. So we look at the electronegativity values. You subtract them, we get this. Well, that would mean polar covalent. It's a polar covalent bond. There's unequal sharing of the electrons. The electrons would be pulled more toward oxygen. So oxygen would have a partial negative and hydrogen would have a partial positive. What about in an OF bond? Well, let's look up the electronegativities. So here they are, subtract them, we get 0.6. So that would be polar covalent, unequal sharing of the electrons. But this time, since fluorine had the higher electronegativity, the electrons would be pulled more toward fluorine. So fluorine would be partially negative and oxygen would be partially positive. What about a bond between Na and O? Well, here we do that subtraction and we get 2.5. Well, that's ionic. That means the electrons are transferred. So the electron leaves sodium and goes to oxygen. What about an O2 bond? Well, that's two oxygens. So I get 0. So that's non-polar covalent. That means equal sharing. So there's no partial negative, there's no partial positive. What about which is more polar? Okay, so in an HO bond, I'm going to subtract the electronegativities. For an NO bond, I'm going to subtract the electronegativities. So which is more polar? Well, the one that has a bigger difference. So HO is more polar. Which is less polar? All right, so let's do the subtractions for the electronegativities. There's FO and there's pH. So which is less polar? The bond between P and H. All right, so now it's going to be time to put it together in class. You're going to do an assignment. But that's it for bonding basics. I hope that you learned something new today.